Modulus of Elasticity and Poisson's ratio of concrete. Concrete is not a truly elastic material, i.e., it cannot regain its original shape from the deformed shape after removal of loading. It is not only inelastic, it is nonlinear also, i.e., stress-strain relationship is not linear. Thus, conventional elastic constants, like modulus of elasticity, Poisson's ratio etc., cannot be defined for a nonlinear, inelastic material like concrete. Even though we have to define these constants for concrete in order to make possible the analyses of structures which are in fact based on linear elastic analysis. The Young's modulus of elasticity is the ratio of axial stress to axial strain under uniaxial loading within the linear elastic range, and it is a constant. For concrete under uniaxial compression, this is valid only in the very initial portion of the stress-strain curve, which is nearly linear, i.e. loading is of low intensity and of short duration. Sustained loading introduces the effect of creep even at low loading intensities. In situations where long-term effects of loading on the structure are negligible, like wind or earthquake loading, we define initial tangent modulus, which is in fact a measure of dynamo-C modulus of elasticity of concrete. In the usual linear static analysis, we define static modulus of elasticity. When loads on the structure are of long duration, dead and live loads, the long-term effects of creep decreases the effective modulus of elasticity of concrete. It is difficult to separate the long-term strains due to creep and shrinkage from short-term elastic strains. Thus, while estimating deflection of reinforced concrete beam, the total deflection is assumed to be the sum of instantaneous elastic deflection, due to loads, and long-term deflections due to creep and shrinkage. Short-term static modulus of elasticity of concrete, E, is used in computing the instantaneous elastic deflection. Various definitions of modulus of elasticity OL concrete, E, are there. Some of them are initial tangent modulus, at specified stress level, secant modulus, at specified stress level, ELC. Secant modulus at a stress level of about 1/3 the cube strength of concrete is generally found acceptable in expressing the average value of E, under the usual service load conditions. As per is 456 to 2000. Short-term static modulus of elasticity of concrete, E, in MPa, is given in terms of characteristic strength of concrete as EC equals 5000 square root FCK. Poisson's ratio is the ratio of lateral strain to the longitudinal strain under uniform uniaxial stress. For concrete, a wide range OL values of Poisson's ratio are obtained, which range from 0.1 to 0.3. For design purposes, a value of 0.15 or 0.2 is considered.